let's go ahead. Just wait for a second. Students, good afternoon to all of you. So we will start the today's session. Okay. So we are dealing with aldehydes, ketones, and carboxylic acids, right? Yesterday we have discussed the introduction, nomenclature, and the preparation of aldehydes. So I have got two questions for you guys to solve from previous year question. Okay, so let's do these two questions as a recall test from the topics that we have discussed yesterday, and then we will move on to the new topic for today. Okay, so as you can see, the question number 1 on the screen, 2-hexene on reaction with O3 and H2O gives products, and the two products formed with the above reaction are. Can you guys find out the answer for this question? Let me know the correct option in the chat box first. Let me know the correct answer. So 2-hexene with the ozone and H2. So is it option A, Vishan? Are you sure? What about others? What others? So only one answer I have got so far. What about other students? Just try solve this question and let me know the answer. 2-hexene on reaction with ozone and water gives. So what is the formula for 2-hexene first of all? So hex means 6 carbon, right? CH3, CH2, CH. Okay, Sneha is also going for option A. Okay, let's check. CH2 and we have CH, double bond CH and CH3. So this is 2-hexene, right? So 1, 2, 3, 4, 5 and 6. So between carbon 2 and carbon 3, we have a double bond. And this is reacting with ozone in presence of water, which is nothing but ozonolysis reaction, right? So yesterday I have told you how to get the product using a trick, right? So you have to break this bond and you have to add oxygen to both the double bonded carbon. So here we get a 4 carbon containing compound, which is CH3, CH2, CH2 and CHO. And the other product is having 2 carbon. So it is CH3, CH2, sorry, CH3, CHO. Okay. So what is the name of these two compounds? The name of these two compounds is, the first compound has 4 carbon. So it is butanal. The IUPAC name is butanal. Okay. And the second compound name is ethanol. Okay, ethanol. And the common name of the second compound is acetaldehyde. Right? Common name of the second compound is acetaldehyde. So we are getting butanal and acetaldehyde. And most of you have given option A as the correct answer. Yes, that is the correct answer. So we get butanal and acetaldehyde from the above range. Okay, very good. So let's go for the next question. Very, very easy question it is. So we have benzoyl chloride. So it is treated with hydrogen in presence of palladium and barium sulfate to form the benzaldehyde. What is the name of this reaction? What is the name of this reaction? Stephens, Gatterman-Koch, Itard, Rosenmans. What is the name of this reaction? What is the name of this reaction? Option D, sure. Everybody is going for option D? Okay. Yeah, yes. Option D is the correct answer. So, benzoyl chloride getting converted to benzaldehyde from hydrogen in presence of palladium barium sulfate is called as Rosenmann's reaction. Very good. So, now let me go for the one last question. Okay. So, you have to identify compound X in the following sequence of reaction. Toluene is there. It is treated with chlorine in presence of H nu and it is forming X. Okay, so find out X. This is also another easy question that I can say. Is it option B or C? Think once again. Think once again. So option C, most of you are going for option C. Okay, so let me check. So yesterday we have seen this reaction under the topic called side chain chlorination, right? Side chain chlorination to form the benzaldehyde. So, and we got option C compound in the place of X, right? So, I told that among these three hydrogen, two of the hydrogen would be replaced by the chlorine. Okay, so what is the name of this compound? Do you guys remember the name of this compound which I have mentioned yesterday? Compound has one name, right? I have asked you to memorize the name of the compound also. Do you guys remember? So none of you remember the answer? Yes, exactly correct. Very good, Tejaswini and Bishan. Good. Yeah, Deva from JNB Guntur. It is benzyl chloride. Benzyl chloride is the name of the compound X. Great. So now let's go into the today's topic. So today we are going to study the preparation of ketones, physical properties of aldehydes and ketones, structure of the carbonyl group, and then chemical properties of aldehydes and ketones. Okay. So let me start with the preparation of ketone. There are three preparations under this topic. Okay. So there are three methods from which we are going to prepare the ketone. The first method is from acyl chloride. Okay, so what is the formula for acyl chloride? RCOCl is called as acyl chloride. Okay, so this is the compound. R dash or RCOCl is the acyl chloride. And it is treated with dialkyl cadmium. Dialkyl cadmium to give RCOR, which is a ketone, and the cadmium chloride is coming out. Okay, so the cadmium chloride that is coming out as a byproduct from this reaction is treated with a Grignard reagent. RMGX is called as Grignard reagent, right? So it is treated with a Grignard reagent, and then on treatment with this Grignard reagent, it forms dialkyl cadmium again, and MgHCl is coming out. So why we are doing the second reaction means, so we are getting back the dialkyl cadmium from this reaction if the cadmium chloride is treated with Grignard reagent. So what we can do, we can use this dialkyl cadmium which we are getting from this reaction, okay, for the preparation of another cycle of ketone. Okay, for the preparation of ketone again. So that is why we are doing the second reaction. Okay, so we can leave this cadmium chloride as such, but if you leave that as such, there is no use. But if you treat that with Grignard reagent, it is forming dialkyl cadmium. So you can use that again for the reaction for the preparation of ketone. Okay. So let me give you one example for this. I have taken ethanoyl chloride as an acyl chloride component. So we have two carbon. It is ethanoyl chloride. So let me write like this so that you can understand this better. C double bond O. Okay, C double bond O. C double bond O. So it is treated with ethyl magnesium chloride. It is, so sorry, it is not ethyl magnesium chloride. This is diethyl cadmium. This is called as diethyl cadmium. The name of the compound is given wrong here, diethyl cadmium. Okay, so what will we get from this? So we get this ethyl group is R group and methyl group is R dash. Okay, so we get R dash COR. So R dash is methyl, C double bond O, and R is C2H5. Cadmium chloride is coming out. So we are getting a 4-carbon containing ketone called as butane 2O. Okay, so this is how we prepare the ketone from acyl chloride. So any doubt from this reaction for anyone? Shall we go ahead with the next reaction? So acyl chloride with dialkyl cadmium gives ketone and cadmium chloride. All right. Shall we move on to the next reaction, students? Say yes or no. Give your answer fast. If you're having any doubt, ask me. Don't feel scared. Don't feel shy. Okay. So now let's go for the next reaction. The second method of preparation of ketone is from nitriles and esters. From nitriles and esters. What is the formula for nitrile? RCN, right? RCN. So this is the formula for nitrile. So nitrile on treatment with RMGX, which is a Grignard reagent in presence of dry ether and on acid hydrolysis, forms a ketone. Okay, this is very easy. I will show you the mechanism. Listen. So take RCN. First add RMGX. So you know how to add the Grignard reagent to carbon, right? So the R part, the alkyl part has to go to carbon and the MgX part has to go to nitrogen. Okay. So basically we are breaking one of the bond, adding R to carbon and MgX to nitrogen. So by adding so you can get an intermediate like this. You will get an intermediate like this. And then on treatment with H3O plus, that is with by doing acid hydrolysis, the entire group which is attached to this double bond will be converted to oxygen. Okay. So we get R dash C double bond O R. Got it? Very easy reaction. So in the same way, esters can also react with Grignard reagent and it also undergoes hydrolysis to produce the ketones. Okay. So esters react with Grignard reagent followed by hydrolysis to produce ketones. So let me give you one example for the preparation of ketone from ester also. Okay. So I have taken methyl butanoate. Methyl butanoate. So this is our COOR dash. Okay. So this is the ester. So if this ester is treated with C6H5MgX, which is a Grignard reagent, it produces C3H7CO C6H5. Okay. So this OCH3 group, it is getting converted to C6H5, the alkyl, which we are using in the Grignard reagent. Okay. Clear? So esters can also be converted to ketone using the Grignard reagent. All right. Can you all able to understand the reaction from nitrile and ester? Yes. Okay. Let's move on to the next then. The third method of preparation of ketone is from benzene and its derivatives. So let me take benzene. So I am going to react this benzene with RCOCl in presence of anhydrous AlCl. And it produces a ketone. So can anyone give me the name of this reaction? We have already studied this reaction in class 11. And also we have studied the benzene derivative reaction with RCOCl with anhydrous AlCl3. Very good. So Nanda Kumari, it is Friedel-Crafts reaction, but to be more specific, can you a little bit refine? Yeah, very good, Rukmini. It is Friedel-Crafts acylation reaction. There are two types of Friedel-Crafts, right? Alkylation and acylation. So this is an example for Friedel-Crafts acylation reaction. Okay, from which we are preparing a ketone. So the example is I am going to take a derivative of benzene, which is toluene. So let us take toluene and treat it with this propanoyl chloride, C2H5COCl. In presence of anhydrous AlCl3, it forms two products. Okay, it forms two products because we have a substituent, right? So it forms two products. Can anyone give me the name of those two products that we get from this reaction? Can anyone give me the name of those two reactions we get from this reaction? So this is an example for electrophilic substitution reaction, right? So this is the electrophilic reagent for this reaction. And the electrophile that we get from here is C2H5CO plus, right? So this is the electrophile. It will go to which position? Ortho, para or meta? Electrophile will go to which position? Ortho, meta position or para position? Simple question I have asked. What is the answer for this? Is it ortho, para directing or meta directing? Very good. So we get ortho, para substituted benzene. Okay. No. Why some people are saying it is meta-directing? No. Nagashri, Sneha, it is not meta-directing. This CH3 group is an electron donating group. Okay. It is an alkyl group. So when electron donating group is present on the ring, the incoming electrophile will go to ortho position and para position. Clear? So we get para product and an ortho product. So first one is para substituted, the second one is ortho substituted. Clear? So para substituted product will be the major product and ortho substituted will be the minor product. All right. So this is how we are preparing a ketone. So this is a ketone, right? So this group is R and we have C double bond O and this is another R group. RCOR. Aromatic ketone we are getting. When electron withdrawing group is present on the ring, then the incoming electrophile will go to meta position. Okay. So all the electron withdrawing groups are meta directing in nature. Is it clear? Yes. Okay, Sneha. Good. So what we have done so far, we have prepared the ketones. Right. So these are the three main preparation of ketone. Now we have one more that is from alcohols. Yesterday itself I told you, if you are going to oxidize an alcohol, you will get aldehyde or ketone, right? So if the alcohol is a primary alcohol, then you will get aldehyde. If your alcohol is a secondary alcohol, then it will give ketone. Okay. So what is the formula for primary alcohol? Primary means RCH2OH. Okay. Secondary alcohol means RCHOH and R. So this is primary and this is secondary. So primary alcohol will give aldehyde and secondary alcohol will give ketone. So we are going to take a secondary alcohol and secondary alcohol on treatment with mild oxidizing agents like PCC will give ketone. Okay, so this is the reaction. RCHOH R dash. On treatment with PCC, it forms a ketone. Okay, so let me take one example. Propan to all. 1, 2, 3. So propan to all. On treatment with the PCC, it is giving propanone. Okay, propanone. We are getting propanone. Is it clear? So these are the 4 methods of preparation of ketones. Any doubt for anyone from the 4 preparation of ketones that we have discussed? Is everything clear and okay to all of you? Is it clear and okay? Any doubt? Do you guys have from the 4 reactions? Okay, clear. That's great. Now let's go for the second topic of today's session, okay, which is physical properties of aldehydes and ketones. So in the physical property of these two compounds, first I am going to discuss about the physical state of these compounds. Okay, physical state. Physical state means whether it is going to be a solid or liquid or gas. So first of all, methanol is a gas at room temperature. What is meant by methanol? What is the formula for methanol? Methanol, one carbon containing aldehyde. So it is HCHO. So this compound is a gas, whereas ethanol is a volatile liquid. Yeah, ethanol is a volatile liquid. Ethanol means CH3CHO. Got it? So one carbon containing aldehyde is a gas. Two carbon containing aldehyde is a liquid. All right. Then coming to ketones. Ketones up to carbon number 13 are liquid. So none of them are gas. Carbon number up till 13 are volatile liquids only. Okay. If you are going for the higher members of both aldehydes and ketones, higher members means more than 15 or 18 carbon containing aldehydes and ketones. Okay. So those are said to be higher members, and those higher members are solids. Higher members are mostly solids. Okay. So these 3 points talks about physical state. Physical state of aldehyde and ketone. Okay. Now next we will discuss about the smell. Lower aldehydes have unpleasant smell. Lower aldehyde means methanol, ethanol, propanol. Okay, so very less number of carbon containing aldehyde. They have unpleasant smell, whereas ketones and higher aldehyde. Okay, all ketones and higher aldehyde, more number of carbon containing aldehyde and ketone. They have fruity smell. Okay, fruity smell, kind of sweet smelling compounds. Okay, so the 4th point talks about the smell, odor. Clear? Now coming to the next point. The next point is about boiling point. Okay, the 3rd physical property talks about the boiling point. The boiling point of aldehydes and ketones are higher than hydrocarbons and ethers. Boiling points of aldehydes and ketones are higher than hydrocarbons and ethers of comparable molecular mass. Okay, so let me take a 2 carbon containing aldehyde, hydrocarbon and ether, and I will show you. So you see here, the first one is an aldehyde. Second is ether. ROR is ether. The third one is an alkane. Alkane is a hydrocarbon, right? So if we compare these 3, which are having the similar molecular mass value, aldehyde is having the highest boiling point value. Okay, so I will give you the reason later. It is due to hydrogen bonding. Okay, it is due to hydrogen bonding. Got it? So aldehyde is having the highest boiling point value because of hydrogen bonding. The next point is about the solubility. Lower aldehydes and ketones are soluble in water due to formation of hydrogen bond. Lower aldehyde means, let me take a 2 carbon containing aldehyde. Okay, ethanol. So I have taken ethanol. So this is one molecule. and this is the other molecule. And they are able to form the hydrogen bonding with the water molecule. So oxygen of both the aldehyde is capable of forming the hydrogen bonding with the hydrogen of water molecule. Okay, so because of this, the solubility increases. Solubility in water increases due to the formation of hydrogen bond. But if you increase the molecular mass, increasing the molecular mass means we are increasing the length of this chain. If I am trying to increase the length of this chain, the solubility will decrease. The solubility will decrease. Okay, solubility in water decreases with increase in the molecular mass. So the lower aldehyde, 1 carbon, 2 carbon containing aldehydes and ketones are highly soluble in water, but more number of carbon containing aldehydes and ketones which are having higher molecular mass are little bit soluble. Okay, they are less soluble in water. Okay, clear for all of you? Is it clear to all of you? The physical state, okay, smell, boiling point, solubility. So these are the 4 physical properties topic that we have covered under aldehydes and ketones. All right. So shall I go for the next topic? The next is structure of the carbonyl group. Okay, structure of the carbonyl group. So what is meant by carbonyl group? C double bond O is called as carbonyl group. Okay, so let me take the structure. So this is the complete structure. R, C double bond O, R. This is the structure of ketone. And if I have RCOH, it is aldehyde. Anyway, both of them are going to have C double bond O. Right? R, C double bond O. This is the structure. So here you can see the RC bonds are called as sigma bonds. RC bonds are called as sigma bonds. Point number 1. And the carbon oxygen is also forming 2 bonds. One is sigma and the other one is pi. So one is sigma and the other one is pi bond. Okay, sigma bond is formed by the head-on overlap and the pi bond is formed by the sideways overlap of the p orbitals. Okay, so there are 3 sigma bonds around the carbon and 1 pi bond around the carbon. Okay, and the hybridization of this carbon is also given. It is sp2. It is sp2. So it is trigonal planar, right? So it is trigonal planar in geometry. Geometry is trigonal planar. Okay. Now let's study something about the carbon-oxygen double bond. So the carbon-oxygen double bond, this bond is there, no? So that double bond between carbon and oxygen is shorter, stronger and polarized. Shorter, stronger and polarized. Shorter means the length, bond length will be small. If the bond length is very less, then bond strength will increase, right? So that's why it is stronger. And polarized means they will take plus minus charge. So the oxygen is more electronegative, so it will take partially negative charge and carbon will get partially positive charge. So the bond will get polarized. Okay. So since carbon is gaining the partially positive charge, it is an electrophile and the oxygen center is a nucleophile. Carbonyl carbon acts as an electrophile and carbonyl oxygen acts as a nucleophile. So electrophiles are electron deficient species, electron deficient center. So it is a Lewis acid, and the nucleophiles are electron rich species. So the oxygen center will act as a Lewis base. So is it clear to all of you? Is it clear? So you can see the bond polarization in the structure also. So the carbon-oxygen double bond is called as polar bond. Carbon-oxygen bond is called as polar bond. So if carbon is taking the partially positive charge, the nucleophile will prefer to attack the carbon center only. Because carbon is electrophilic in nature, right? So the incoming nucleophile will try to attack an electrophile. Because the entire organic chemistry is nothing but the reaction between an electrophile and a nucleophile. If this carbon is an electrophile, then the nucleophile which is coming from outside will come and attack this carbon electrophile. Okay? So the nucleophile prefers to attack the carbon center. Is it clear to all of you? So the very important points that you have to note down is, first is there are 3 sigma bonds and 1 pi bond around the carbonyl carbon. Okay. And the second point is the hybridization of electrophilic carbon is sp2. And the geometry is trigonal planar. The third point is about the carbon-oxygen bond. Okay, it is shorter, stronger, and polarized. Fourth one is electrophilic carbon is a Lewis acid center and the oxygen is acting as a Lewis base. All right. Then the sixth point that you have to keep in mind is the nucleophile which is coming from outside will prefer to attack the carbon. Okay, it will come and attack the carbon. So is it clear? So this is all about the structure of the carbonyl group. Okay. And the electron pairs which you can see here in the pink color. Okay. They are nothing but the lone pair of electrons and oxygen. Each oxygen will have 2 lone pairs, right? So those are the lone pairs of oxygen. So any doubt from structure of carbonyl group for anyone? Able to understand? Able to understand? Yes? Okay. So now let me summarize the things that we have discussed from preparation of aldehydes. Okay. So I will give you the very important reactions. Okay. Preparation of aldehydes. So the very first is Rosenmann's. Second is Stephens. Third is oxidation using PCC. Fourth is oxidation using ozone. It is not oxidation, sorry. It is reductive ozonolysis, right? Then the very important is ETAD reaction. So we have covered all these in the yesterday's session. Now today we have started with the preparation of ketone. The very first reaction is from acyl halide and the next is from nitrile and ester. The third is Friedel-Crafts acylation reaction. And coming to the physical property, the very important physical property that you should not forget is the boiling point property. Okay. The boiling point of aldehydes and ketones are higher than hydrocarbons and ethers. Okay. And after this, we have discussed some 6 points in the structure of the carbonyl group topic. Okay. So today we have covered 3 topics: preparation of ketone, physical properties, and structure of the carbonyl group. Now I am going to enter into the chemical properties or the chemical reactions of aldehydes and ketones. Shall we enter into this topic? Are you all ready? Are you all ready? So please listen, have the chemistry notebook with you and the pen, the pencil with you. Take the notes. Okay. So shall we start the chemical reactions of aldehydes and ketones? If you say yes, I will go ahead. Okay, thank you, Bhagat. So the chemical reactions, the very important topic it is. Okay, chemical properties or the chemical reactions is the very important part of this lesson. So please do concentrate more. Let me give you the list of chemical reactions first. So these are the reactions we are going to discuss under the chemical properties. The very first is nucleophilic addition reaction. The first is nucleophilic addition reaction. Harish is asking me to show the slides of preparation of ketone. Okay, you are asking me the summary slide, Harish? Yes? Is this the slide you want? Or you want me to show at the last? Okay, okay, okay. Okay, fine. So all of you look into the reactions. The very first is nucleophilic addition reactions. Okay. The second is reduction of aldehyde and ketone. Third is about oxidation. Fourth is reaction due to acidity of alpha hydrogen. Under that, we will discuss these three. Okay, iodoform, aldol, cross aldol. Then the fifth reaction is Cannizzaro. Sixth is electrophilic aromatic substitution reaction, which you all are familiar with. Okay. So now let's go into the very first reaction, which is called as nucleophilic addition reaction. So from the name itself, you can understand that a nucleophile is going to get added into the aldehyde or ketone. Okay. So now let's see the mechanism of this addition of nucleophile. Okay. Listen. So what I have taken initially, we have an ketone or aldehyde. This compound can be an aldehyde or ketone. And to this, the nucleophile is getting added. So I have already told you that carbon is the electrophilic center and the nucleophile will try to come and attack the carbon. So it is attacking the carbon and the electrons are getting delocalized towards the oxygen. So we are getting O minus here. And on hydrolysis, the O minus will be converted to OH. Okay. Is it clear? So basically, if you want to get the product directly from the reactant, you listen. So we have C, R, R, double bond O, right? So to this, we are adding a nucleophile. The nucleophile is H2O. Nucleophile is H2O. So H2O has H plus and OH minus, right? So break the double bond, add H plus to oxygen and OH to carbon because that is a nucleophile, right? Negatively charged species. So what will you get? We have a carbon attached to two R groups and now we have one OH and another OH. Clear? Clear for all of you? So this is the nucleophile and this is the OH part of the reaction. This is the nucleophile and this is the OH part of the product. This is the carbon. Clear? So this is how you have to add. Without forming the intermediate, you can get the product directly. I will give you the examples of nucleophilic addition in the next slide. Okay, don't worry. So now listen the mechanism alone. So add nucleophile to carbon and hydrogen to oxygen. That's all. Hybridization will change from sp2 to sp3. So here we have only three groups attached, right? So it is a double bonded carbon. So it is sp2. But here all the bonds are single bond. All are sigma bonds. So the hybridization is sp3 for this carbon. Hybridization will change on addition of nucleophile. Okay. So now this group can be an aldehyde or this compound can be a ketone. Now let's study some information about this. Aldehydes are generally more reactive than ketone in electrophilic addition. Why? Why aldehydes are more reactive? The formula for aldehyde is RCHO, right? And the formula for ketone is RCOR. So these R groups, which are called as alkyl groups, they are electron donating groups. They are electron donating groups. Very good. Very good. They are electron donating groups. In case of aldehyde, we have only one electron donating But in case of ketone, we have two electron donating. Okay. So there are two factors which affects the reactivity. The very first factor is the crowdedness. Very first factor is called as crowdedness, or you can say steric effect, steric hindrance. Okay, steric hindrance. So here we have one R group. So aldehyde is less hindrance compound. Yeah, steric factor. And only one electron donating group is attached, right? So the more electron deficiency will be observed at carbon. But if you come to ketone, it is having two bulky groups. Both the groups are alkyl groups. So we have two bulky groups. So it is more hindered. Okay. The carbon is more hindered by the two alkyl groups. And since there are two people who are helping this carbon, it is less electron deficient in nature. Okay. So the first factor talks about, this hindrance factor talks about the steric factor. Okay. Steric factor. And the second point talks about the electronic factor. Okay. Electronic factor. So these two factors are responsible for the reactive nature of aldehydes and ketones. Can you all able to understand? Aldehyde is having one small hydrogen and one bulky group. Ketone is having two bulky group. Okay. So it is, this carbon is more electron rich. The carbon is more electron rich. So another electron rich nucleophile cannot come and attack this electron rich center. It is less reactive, right? Electron rich can attack electron deficient more effectively. So that's why aldehydes are more reactive than ketones. So can you all able to understand the point which I'm trying to say? And because of steric reason, here we have a small group, right? Hydrogen is a small atom. So the nucleophile which is coming, it can come easily and attack this carbon. But here we have bulky groups. So they will not have enough space to attack this carbon. The nucleophile will not have enough space to come and attack the carbon. So the reactivity will be very less. All right. Very good. So steric factor and electronic factor are the two reasons for aldehydes to be more reactive than ketone. Please don't just memorize the points alone. Understand the concept and then you memorize. Clear? So now let me go ahead with the addition of some compounds. Let us go for some examples. So the very first nucleophile is HCN. Very first reaction under nucleophilic addition reaction is addition of hydrogen cyanide. So this is the subcategory of the first reaction. Okay. The first chemical reaction is nucleophilic addition reaction. And this is the first subtitle. Addition of HCN. So HCN will produce CN minus nucleophile. Okay. And we are going to take an aldehyde or ketone. And we are going to add this HCN. So add cyanide, it will go to carbon. And if you hydrolyze, it will produce CN and OH containing compound. So if a compound has CN and OH, it is called as cyanohydrin. This is important. Okay, if your compound has CN and OH, it is called as cyanohydrin. Suppose if I have C double bond O, CH3 and CH3 with HCN, what will I get? I have to break the bond and the addition molecule is separated into H plus and Cn minus. Always add hydrogen to oxygen and the nucleophile to carbon. So what will I get? Already we have CH3, right? And OH. Now a new bond is formed with Cn. So this is this compound. Cn and OH. Cyanohydrin. All right. This is the addition of hydrogen cyanide. Now the second is addition of sodium hydrogen sulfide. Sodium hydrogen sulfide. NaHSO3. Okay, we are going to add this. So take an aldehyde or ketone and add NaHSO3. So how can we separate this? Na plus HSO3 minus. Na plus HSO3 minus. Na plus HSO3 minus. Okay. So the nucleophile HSO3 minus will get added to carbon and Na plus to oxygen. We get an intermediate like this. Okay, always add the negative part to carbon and positive part to hydrogen. Okay, so now if you see this compound, here we have sodium attached to oxygen. We always used to have hydrogen attached to oxygen, right? Yes or no? But here we have sodium. So what is happening, the hydrogen which is attached to this HSO3, so that is going to get transferred here. So the sodium and hydrogen, they are going to undergo the proton transfer step. So after getting transferred between these two positions, they form a compound like this. So sodium will take the place of hydrogen and hydrogen will take the place of sodium. Okay, both have interchanged their place. Now the compound is perfect. So it is called as hydrogen sulfide addition compound, which is crystalline in nature. Okay, so is it clear? Is it clear for all of you? So just do a proton transfer step here to get the final product. Product is crystalline in nature. So this is how you have to add. Now coming to the third addition, which is addition of Grignard reagent. So you all know the formula for Grignard reagent, right? What it is? RMGX. So how we are going to add this to aldehyde? RMGX. Negative part is R, positive part is MgX. So it is very easy. Add the R group to carbon and MgX to oxygen. Okay, so you will get a compound. Then on hydrolysis, the entire OMgX will be converted to OH. So here we are getting a secondary alcohol, CHOH. So it is secondary alcohol. In case of ketone, so this is an aldehyde, right? So from aldehyde, I am getting secondary alcohol. If I take ketone as the reactant, then tertiary alcohols will be formed. I will show you. So this is a ketone. RCOR is ketone. And by adding R to carbon and MgX to oxygen, and then after doing hydrolysis, I will get a tertiary alcohol. I will get a tertiary alcohol. Okay. So first of all, R will go to this carbon, MgX will go to oxygen, and they will form RCOMgX. And here we have, this is R double dash, right? This is R dash. And here we are getting an R. Okay. Then if you do the reaction with H2O, the entire, the O minus MgX plus, the entire group will be converted to OH. So that is what is given in the product. C, R, R dash, R double dash with OH. So what is this? COH group, tertiary alcohol. And CHOH means it is secondary alcohol. So from aldehyde, we get secondary alcohol. From ketone, we get a tertiary alcohol. This is how you have to learn. Clear? So do you have any doubt from the third addition of nucleophile? Yes? Or no? No. So everything is clear and proper for all of you, right? Okay. So this is enough for today. So tomorrow we will continue this nucleophilic addition. We have some more nucleophiles, okay? So we will add the other nucleophiles also in tomorrow's session, and then we will continue the lesson, okay? Thank you so much for attending the class, students. So Harish, you can stay back, okay? You have asked me to show something, right? So you can stay back. Others, can get ready for your next class after completing the feedback. Okay, I have launched a poll. You guys can give your answer in the poll. 5 questions are there. There are 5 questions. Please answer for all the 5 questions and then get ready for your next class. All right. Thank you so much. Take care.